Okay, last thing for us to do today is to evaluate whether the common statement is true or false. But let's start by filling out the truth table. Well, we don't know what the truth table is yet, but we're about to find out. The truth table for P and Q and P or Q. So what the heck is a truth table, first of all? Well, here's an example of it. And here in the first column, I have the statement P. Second column, I have the statement Q. And what you see below, those are the possible values. Those are possible truths for P or Q. I mean, it's all the possibilities. P could be true, and Q could also be true. Or P could be true and Q could be false. P could be false and Q could be true. Or P could be false and Q could be false. Those are all the possible combinations of P and Q being true or false, right? So this is the most general table for the truth of P and Q. The P and Q are some statements, right? I don't know if they're true or false, but this table is representing all the different possible variations of P and Q being either true or false. That's the first two columns. Now, in the second two columns, what I have is what would happen under those circumstances if I look at the P and Q now, if I look at that compound statement. And now earlier, remember in the box above, here, let me erase some of this superfluous markings so that I can focus a little better. I want to focus in on the box at the top that we looked at earlier. Okay, let's just erase all this stuff again. So earlier in that box above, we learned about the ands, and we said that in the ands, let's use a yellow this time, that P and Q is true, is only true if both are true, right? Both P and Q are true. So looking down at my truth table here, which of these four combinations, for which of those are they both true? And the answer is just the top right there, right? They're both true in that situation. That's the only time it happens. So that makes this true right here. P and Q is true as long as P and Q are both true. And otherwise, it's false, right? That's the only time where they're both true. If you look here, there's a false there, there's a false there, and they're both false in the bottom. So the rest are just going to be false. And this brings me to my first little tip. When eventually we're going to have a bunch of these different operators, and your job is going to be to fill out these big truth tables or even just to determine the truth of a common statement. And when you're dealing with an and, what you look for is where are they both true? Fill that truth in, and then the rest you just fill it false. You don't have to think about the rest. Once I know I have my only true cases, then just look at the rest as all automatically being false. Let's write that down. That's worth remembering here. Just a little tip for ands. The ands. Or how should I say this? Let's just say P and Q. Look for where P and Q are both true. Once you find that one, then the rest of the table is false. Or the rest of the time, let's say P and Q is false. Okay, what about P or Q? Well, before I fill it in, try it out based on our definition at the top. See if you can figure it out. All right, so I'm assuming you paused and tried it. P or Q, it's true as long as either P or Q is true, or also if both are true. So that means it's pretty much always going to be true, that means, right? So by the definition, as long as one or the other is true, like here's a true, here's a true, here's a true, then the whole thing is going to be true, right? The only time it's not true is when they're both false. So that's the one false. All right, so looking for a true, that's effective, that works. And you can totally do it that way. And if that makes sense to you, then you can do that every time. But personally, I think it's a little more efficient to look for the false. Because when you're talking about an or, and OR is only false one time, and that's when they're both false, right? The rest of the time it's true. So this will shorten your work very slightly. That's bringing us to my second tip. The tip for P or Q. And that is to look for where P and Q are both false this time. And that's going to make the whole thing false, yeah? False. And then the rest of the time, P or Q is going to be what? It's going to be true. So you see they're both false here. That makes the P or Q false. The rest of the time it's true. You see I got the same result as when I went by the definition last time. Yeah. True, 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 false. Okay, this is a table that you should be able to recreate yourself from memory without having to use any reference. Okay, now let's get down to the last questions. So the last question is what the heck is going on here? Well, we've got three statements. We've got P, we've got Q, and we've got R. So we've got three. Now we're introducing a third statement, yeah? Use a new letter. Three statements, and we're told that, well, I don't know what the statement P is, but I do know that it's something true. Okay? P is some true statement, whatever it is. Q is some false statement. I don't know the actual statement, but I know it's some false statement. And R is some true statement. Okay? So with that information, I'm going to decide what about these compound statements? Are they true or false? Let's start with the easiest one. And before I show you answers each time, make sure that you're trying them on your own. We'll do them one at a time. 18. Is 18 true or false? Well, the first thing that you do when you evaluate a question like this, it's kind of similar to how we did that set algebra thing. You're going to just copy down the truth value in place of the statement. So if I have negation P, I'm going to replace that with negation of true because P was a true statement, right? So 18, negation of true, and I know that the negation changes the truth value to opposite. Remember the note at the bottom of the last page, right? Bottom of the first page. So that means if I take the negation of true, I'm going to end up with a false statement, and that's the answer for 18. Yeah, the answer, the whole answer for 18 is really this whole entire thing. You're showing your work here by starting with that first statement, just replacing the truth value. And just like with the set theory, if you do that one step, you're automatically going to get partial credit. You get 1 point for free just by rewriting the truth value in there. So that's an easy point. Okay, number 19, P or Q. So just like before, I'm going to replace P or Q with the truth values for each of those. P was true. I got an R, and Q was false. Okay, so now I evaluate this. True or false? I know or. As long as one or the other is true, it's true. And so true or false is going to become true. That's your answer right there. Okay, so I've shown you how to do the entire problem, how to also show your work. This is how I expect you to show your work here. Okay, number 20. P and Q. That would be true and false. We know an and statement is only true when they're both true, but that's not what we have here. One of them is false. So the resulting thing should be false. Yeah. You can also refer to the table over here. True and false would be this situation here. I'm looking at the and, so that's it right there. That would be the answer, right? Okay, guys, I'm going to assume that you have this down. I'm going to erase so I can make space for the next questions. Let's get rid of this guy up here too. Eliminate some distractions. Get that out of my way. Okay. So where we're at, number 21. So 21, I'm going to just copy down the thing down with the truth values instead. So instead of negation P, I'm going to write negation of true or Q, which is false. All right, here we're going to use a little of order operations. the negation comes before the or. So this is something I gotta actually tell you real quick. So here's the order of operations. You know how in set theory? Okay, let's have a little aside here. Order of operations. Okay, remember in set theory, we had this order of operations. We did number 1 parentheses, and then number 2 was complements, which is like, complements are really the analogous thing to negations in set theory in logic. And then we had intersections or ands and unions or ors, right? So guess what, guys? When we're doing logic, we follow the same order of operations. Parentheses. And then negations. And then ands and ors. Later on for logic, we're going to add some other operators in the coming sections. But for now, those are the 3 that we've got. Yeah. So we have the same order of operations, just like set theory. Okay, so what does that mean then? When I'm looking at 21, what should happen first? The negation happens first. So I'm going to end up with not true becoming false. I have false or false. False or false I know to be false. Because remember, or it's got to have some true to be true, right? So that's the answer right there. Okay, 22. Negation P would be negation of true, or negation of Q is negation of F. First, the negations happen. So the negation true becomes a false, or negation false becomes a true. So I've got false or true. Remember, or is true as long as one or the other is true, and I have a true in the right, so the end result is true. Okay. Make sure you're trying them out before you watch the answer, yeah? Because that's where you're getting your practice in. Okay, number 23. We've got R, oops. Sorry, I meant parentheses. R, which is true statement, or Q, which is a false statement, close parentheses, and P, which is a true statement. Okay, so I'm going to start with the parentheses first. True or false becomes a true, right? That's the parentheses. Bring down the rest of that statement. So I have true, and I know true and true is a true statement. So that's 23. And then the last question, 24. I've got, P or Q in parentheses. That's a true or false statement. Oops. In parentheses. And negation R, or R was a true statement, so negation of a true statement. Here again, parentheses first. True or false is a true statement, right? Or is true as long as one or the other is true. And negation true. I'm just bringing that thing down. Okay, next would be the negation here, yeah? So negation of true is going to be a false statement. That's going to give me a true and false, copying the rest. And I have true and false, which is a false statement. So the end result is false. Now, guys, on an exam, I expect you to be able to evaluate these things, and not just evaluate them, but to also show some kind of thought process like this. If you only give the answer here, then who's to know that you weren't just lucky because you have a 50-50 chance of getting the right answer, right? So what's more important than getting the end result is to actually show your entire thought process. So be able to write this entire set of lines to show your work. Okay, guys, and with that, we are finished with the first section. If you have any questions, then feel free to email me, or maybe also just try to get more exposure to this stuff, the typical thing, right? Either read the book or even look up YouTube videos on set theory. Not set theory. Logic and the and the or. And also the negation. And qualified negations. Those are the topics we covered, right, today. Let's just recap what we did today. We talked about what a statement is. It's true or false, right? We talked about how to take a negation, and in particular, taking negations of these qualified statements. So these are the 4 types and their negations, right? And we did some practice with that. Talked about the negation of the true statement is false and vice versa. And then we talked about the and the or. Translating some back and forth from English to the symbol form. And then lastly, just evaluating compound statements with and or and negations. All right, guys, have a good one. I will see you in the next section.